5.2 graph of reciprocal trigonometric function. In the last topic, we did the graph of sine x, cosine x, and tan. Now we want to do the reciprocal of that, 1 over sine. So 1 over sine we know is cosecant, right? Basically, we want to graph cosecant. The same method I'm going to use. Let's share another whiteboard. So I'm just going to quickly put this circle, right? For here is 0 degree. Here is 90 degree, 180 degree. Here is 270. And then we come back to 360 degree. The point that we put is 1 and 0. X and Y component, right? Here is 0, 1. It's -1, 0. And this point is 0, -1. And then you come back to the 360, again is 1 over 1, 0. I showed you that sine x, it's equivalent to Y component, cosine x equivalent to the X component, and tan x is Y component over X component. For the reciprocal of that, see, for cosecant, which is equal to 1 over sine x, or sine theta, if you want to say. 1 over sine is 1 over y. For secant is 1 over cosine is equal to 1 over x component. I prefer, instead of the x here, I put theta for you to see this is an angle, right? Don't mix it with this x. This is angle. Theta. Theta. In front of this trig ratio, put theta. And tan theta is equal to, sorry, I mean cotan, because the reciprocal of the tan is what? Is cotan. Cotan theta is 1 over tan theta is equal to reciprocal that we just switch the numerator and denominator. This x over y. Okay, first, let's say we want to do y is equal to cosecant theta, which is equivalent to 1 over sine. Again, I'm going to put the points that I do is theta y. We do for 0 degree, we do for 90 degree, pi over 2. We do for pi, which is 180 degree. 3 pi over 2 and 2 pi. So pay attention, Theodore. I'm gonna do the first one and you do the second one. Since 1 over sine is 1 over the y, the sine is y component, y over y component. Here for 0 degree, y component is what? 0. It's gonna be 1 over 0. Then what? 1 over 0, because 0 is in denominator, is not defined. Can you tell me what is this cosecant of the 90 degree or pi over 2?
0, negative 0, negative 1.
Okay, 90 degrees here. Okay.
Yeah.
Cosecant is 1. Yeah. Cosecant is 1 over sine. Sine is y component, right? Is 1 over y component. What is the y component here?
0.
Y component.
Oh.
1, right?
Okay.
1.
Yeah.
1 over y component. 1 over y component, there is 1, which is 1. Now do for pi, 180. Cosecant of 180 is 1 over what?
Negative 1.
Y component. Here, y component is what? 0.
0.
1 over 0, again, 0 is in denominator, is not defined. Do it for 3 pi over 2. 3 pi over 2 is 1 over what? Negative 1, right?
1.
So it's equal to negative 1. 2 pi, for 2 pi, what is it? 1 over? 2 pi is 360.
0.
0. Since the 0 is in denominator, it's not defined. Now I can graph that. Just be careful about the graph. So here is pi over 2. Here is pi. 3 pi over 2. 2 pi. For 0 is not defined, means I have an asymptote here, right? I'm just put my asymptote as red. See, I have asymptote at 0. At pi, I have asymptote. And 2 pi. Okay. Now, at pi over 2 is 1, so is there. Pi over 2 is 1. And 3 pi over 2 is negative 1. Now what? I need to go toward asymptote. In first quadrant, see CAST. In first quadrant, the sign is positive. So I have to go toward the asymptote, make sure I'm going up. I'm not going down, because if I go down, some part of that will be negative. In second quadrant, again, sign is what? Positive. So I have to go up toward asymptote. In quadrant 3 and 4, sign is negative, right? Because just tan here is positive, means sign here is negative. Cosine here is just positive, means sign is again negative here. Means when you do here, you have to go down toward asymptote, like that. And here you have to go down toward asymptote. This is quadrant 3 and 4. As you see, you can repeat that. If you want to repeat the other parts, again, you just know, again, this is going to be negative 1 here, and there you have an asymptote there. You need to put the dotted line, right? Then here C is minimum, so of course this is gonna be a maximum here. Then you have to go toward asymptote this way, go toward asymptote. But the repeating part is just from here to here, right? This, and then it's repeated itself. So as you see, this is the cosecant. Now we can do, just put a line here. Now I'm gonna do, oops. I'm gonna do secant. Y is equal to secant theta. For secant theta, secant is 1 over cosine. 1 over x component. I put again so here is 0, pi over 2, pi, 3 pi over 2, 2 pi. Now, secant is 1 over cosine. Cosine is x component, right? I'm going to do for 0 angle. For 0 angle, 1 over x component. X component here is 1. It's going to be 1 over 1, which is 1. So can you tell me what is 4 pi over 2 or 90 degree? What should I write?
1.
1 over what?
1 and 1.
No, 1 over x components. Cosine is
Cosine.
x component. What is x
0.
component? 0.
0.
So since a 0 is denominator, is not defined, or this is asymptote. Do it for 180 degree or pi. What is the secant of the pi? 1 over what?
Negative 1.
Negative 1 and
0.
2,
Yeah.
no, negative 1. 1 over negative 1 is negative 1. For 3 pi over 2, 1 over
0.
0, which is not defined because the 0 is in the denominator. For 2 pi is 1 over
Is 1.
1, which is 1. 1 over 1 is 1. Okay, so let's just graph this. I'm gonna graph this one quickly here. Okay, 1, 2, 3, 4. So this is 2 is pi over 2. Here is pi, 3 pi over 2, 2 pi. I put the asymptote with the red. At 0 is 1. At pi over 2, we have asymptote now. And at pi is 3 pi over 2 is an asymptote again. I can assume that because the pi over 2, of course, the negative pi over 2, because it's symmetric, right? It's gonna be negative pi over 2, but it's extra. Now, at 0 is 1. So let's just see if this is this point. At pi over 2 is, for pi is negative 1. At 2 pi is again positive 1. Now, see here, cosine, right? 1 over cosine. Cosine in first quadrant is positive, means this point I need to go up, make sure it's positive. From 0 to pi over 2 is first quadrant. Second quadrant, the cosine is negative. So if you do this, so you have to go down, make sure it's negative. Here in third quadrant, the cosine is negative, so I have to go down. In fourth quadrant, the cosine is positive. So from 3 pi to 2 pi is fourth quadrant is positive, so I have to go up. If I want to just draw another one, again, I have to go to the first one, right? Because after 4, again, you have to go here. Everything is positive, so you're going toward going up. But as you know, the period here, minimum to minimum, right? Is from here to here is your period. Next, we will talk about the period. Period is going to be 2 pi, the same as cosine. The period of the cosine is 2 pi. Anyway, I'm gonna now draw y equal to cotangent theta, which is equal to 1 over tan. 1 over tan is x component over cotangent is x component over y component. Then we do the points theta and y. Again, for 0 degree, pi over 2, 3 pi over 2. Oh, I forgot pi here. Pi, 3 pi over 2, and 2 pi. Okay, I'm gonna do the first one. For 0 degrees here, I know it's gonna be x over y component. 0 degree, x component is 1, y component is 0, is 1 over 0. Can you do the next one, which is not defined? For pi over 2, what is it? Theodore? Again, this is x over y component for cotan. So x component is 0, y component is 1. So x over y component, 0 over 1. 0 over 1, which is 0. Now tell me for pi. Again, x over y component. What is it? X component over y component.
Negative
1 over 0, right?
1, 0.
Negative 1 over 0, which is not defined. Tell me the next one. 3 pi over 2.
Is 0, negative 1.
0 over negative 1 is 0. For 2 pi or 360.
1, 0.
1 over 0, which is not defined. Whenever you have 0 in denominator, it's not defined, and it's going to be your asymptote. Now, just graph it quickly. One, 2, 3, 4 is pi over 2. Here is pi, 3 pi over 2, and 2 pi. I'm going to put the asymptote again with red. So for 0, we have asymptote. Oops. At pi, we have an asymptote. At 2 pi, we have an asymptote. Now, cotan is 1 over tan. So in first quadrant, everything is positive. So I need, okay, I didn't do pi over 2. Let me just do pi over 2 as well. So pi over 2 is 0. 3 pi over 2 is 0. So in first quadrant, from 0 to pi over 2, everything is positive. So you have to go toward the asymptote. So I have to go up. From 90 degree to 180, the tan or cotan, they both are negative, right? So it's going to be negative. You have to go down toward asymptote. Make sure your graph is negative. In third quadrant, again, positive, true? Tangent is positive, or cotangent. In fourth quadrant, the tan here is negative, so you have to go down toward asymptote. And it's going to repeat itself, right? As you see the period here, this is repeating. From here to here is the repeating part. Is period is here. So period gonna be pi. The same thing, see, from minimum to minimum is your period, right? Or here from maximum to maximum. It's from negative pi over 2 to 3 pi over 2. The length here is 2 pi. So this is period. Period here is 2 pi. Make note that the period of sine theta was 2 pi as well. The period of cosine was 2 pi as well. And here, period of the tan itself was pi, okay? Here, since we have minimum and maximum, we do not have minimum or maximum. See, it go down forever, means there is no minimum point. And here, this part is go up forever, there is no maximum. Same here, because it's go up and this part go down forever. There is no maximum minimum. Same thing here, just go up forever, down forever, no maximum minimum. How about amplitude? We do not have amplitude. How about the domain and range? The domain and range, the domain gonna be, you have to exclude your asymptote here, right? If I want to do domain here, gonna be XER. X cannot be what? Here, 0, pi, 2 pi. 0, pi, 2 pi. You can say dot, 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 n pi. N is 1, 2, 3, 4, 5, 6. So this is your domain. And for range is YER. And y greater than 1, greater equal than 1, and y less than equal to -1. This is your range. There is nothing between 1 and -1. See, there is no y. The same thing here. I can do the domain XER. X cannot be your asymptote. Is pi over 2, 3 pi over 2, next one gonna be 5 pi over 2. As you see, the odd number over 2, right? So if I want to generalize that, it's gonna be 2n plus 1, 2n plus 1 pi divided by 2. 2n plus 1 is the odd number over 2. This is my domain, and for my range is y belong to real number, y greater equal than 1. So this is that part. See, this is go up from 1. And here, y less than equal to -1. Same thing I can do that. Here is x belong to real number. X cannot be what? 0 pi 2 pi. 0 pi 2 pi. I can generalize that. How? Say x cannot be a dot dot dot, cannot be n pi. N is any negative positive number from -1, negative infinity to positive infinity, integer. For range, YER, there is no restrictions. You see, it's go up, go down forever. Means it's included all of the positive and negative values of y. Do you have any question, Theodore?
No.
Okay, so let me